Hello everyone, I am K. Kusma and my team member is M. Likita and we are from Cybersecurity and we are doing this presentation under the guidance of Dr. M. Prasad, Associate Professor and he belongs to Department of CSE. And here we are going to explain topics about disk management, disk formatting and boot blocks. Now I am going to explain about disk management. Disk management is a process of organizing, optimizing and maintaining computer storage resources to ensure efficient data storage and retrieval. It involves dividing the hard disk into partitions, formatting these partitions to different file systems, and regularly maintaining and optimizing disk performance. The goal of disk management is to provide a convenient and organized storage system for users to store and access their data, as well as to ensure that the computer runs smoothly and efficiently. Efficient disk management helps in maximizing storage capacity, improving system performance, and ensuring data integrity. The key components of disk management are partitioning, formatting, volume mounting, and drive letters. And partitioning. Disk management involves dividing a physical disk into separate partitions, allowing different file systems to coexist on the same drive. And formatting is about the process prepares a partition for use by creating a file system which includes the necessary data structures for organizing and accessing files. And volume mounting and drive letters. Disk management assigns unique identifiers known as drive letters to partitions, allowing the operating system and users to access them. These tasks help ensure a convenient and organized storage system for users and improve the overall performance and stability of the computer. And some common disk management tasks are resizing partitions, creating mirror or stripped volumes, disk cleanup and defragmentation, managing disk properties. Allocating disk space to partitions is a key task in disk management. The process involves dividing the hard disk into separate areas, each of which is called as a partition. Resizing partitions. To resize a partition, you can either increase or decrease its size. You can use the disk management tool to shrink or extend the volume, but you may also need to move data around to do this. Creating mirror or stripped volumes. It facilitates the creation of the RAID configurations such as mirroring or stripping. Disk cleanup and defragmentation. These tasks involve removing unnecessary files and optimizing data placement on the disk to improve performance. Managing disk properties. Disk management provides tools to view disk properties, monitor use, and perform maintenance tasks to ensure reliable storage operations. Defragmenting and optimizing disk performance are tasks in disk management that can help improve the speed and efficiency of your hard disk. Disk management tools are software programs that allow you to manage the storage space on your hard disk. Common disk management tools include Windows Disk Management, Disk Utility on Mac OS, and gparted on Linux. And these tools allow you to easily manage the storage space on your hard disk without needing to use the command line tools. Purposes of disk management. Disk management is an important functionality provided by the operating system that can be used to create, delete, and format disk partitions and much more. Disk management enables users to view, create, delete, and shrink the partitions associated with the disk drives. And some other purposes of the disk management are optimizing storage space. Disk management helps in efficiently utilizing available storage space by creating partitions which act as separate units of storage within a physical disk. Improving performance. By organizing data into logical units, disk management can enhance system performance by reducing fragmentation and enabling quicker access to files. Improving performance. By organizing data into logical units, disk management can enhance system performance by reducing fragmentation and enabling quicker access to the files. And now I am going to explain about the disk formatting. Disk formatting is a process of preparing a storage medium such as a hard drive or SSD for storage. It involves setting up the necessary file system structures and metadata. We use disk formatting to create a clean, organized file system that allows for efficient data structure, retrieval, and management. Is the disk formatting process. Picture your storage device as a clean canvas, ready to transform into a structured repository for your digital data. Disk formatting initiates this transformation by organizing the storage space, setting up the file system, and establishing the crucial metadata. Think of it as an artist preparing their palette before creating a masterpiece. Disk formatting is the canvas preparation, ensuring the storage device is ready to accommodate and efficiently manage your data. There are four types of disk formatting. Now let's explore the types of disk formatting. Firstly, low level formatting. This is the foundational formatting type that involves dividing the storage devices into tracks and sectors. It's like dividing a vast landscape into organized plots. Low level formatting creates the physical structure necessary for data storage. And coming to the high level formatting, building on the foundation laid by low level formatting, high level formatting adds another layer of organization. It involves creating a file system, allocating space for directories and files. It's like designing the blueprint for your storage, specifying where each building or file will reside. And now, quick formatting. For those looking for speed, there is a quick formatting. This type skips certain verification processes, makes it faster than a full format. It's like giving your canvas a quick priming before starting a new project. And lastly, full formatting. On the other hand, full formatting is more thorough. It not only prepares the canvas but also checks for errors and bad sectors. It's like conducting a metacolors inspection of the canvas to ensure a flawless foundation for your digital creations. Types of disk formats. File system formats. And firstly, FAT, File Allocation Table, a legacy file system known for its compatibility with various operating systems, but with the limitations on file size and security features. And new technology file system, widely used in modern Windows environments, offering advanced features like file level security, encryption, and support for large files. XFAT, Extended File Allocation Table, designed for a flash drives and other removable media, providing compatibility across different operating systems. And disk formatting process. Firstly, allocation of sectors and clusters. Sectors are the basic unit for storing data on a disk. Clusters are group of sectors and they form the basis for file storage. And next, creating file system structures. This includes the creation of file allocation tables, directories, and other metadata that help organize and manage files on the disk. And marking bad sectors, identifying and flagging sectors that are unreliable or defective, preventing data from being stored in those areas. And coming to the best practices of disk formatting, firstly, quick format versus full format. Quick format only initializes of the file system structures, while a full format checks for bad sectors. Choose the appropriate option based on the situation. And periodic disk maintenance. Regularly check and maintain the file systems for errors and consider reformatting if performance issues persist. And data backup before formatting. Always backup important data before initiating a format as the process will erase all the existing data on the disk. Disk formatting is an action which must be done with caution as it deletes data and removes programs installed. Backup of the necessary data or applications are required. Disk formatting takes time. Frequent disk formatting can gradually decrease the life of the hardware. And the uses of the disk formatting are when a new operating system is going to be used by the user. It is also done when there is a space issue and we require additional space for the storage of the more data in the drives. When we format the disk, then the existing files within the disk is also erased.
Now, I am going to tell you about the boot blocks. Boot blocks are specialized data structures located at the beginning of storage devices like hard drives or SSDs. They contain the initial instructions needed to boot up the computer. These blocks contain essential instructions and code necessary to initiate the boot process when you power on your computer. The full bootstrap program is stored in the boot blocks at a fixed location on the disk. A disk that has boot partition is called a boot disk. Think of boot blocks as the opening lines of a script. In a theatrical performance, they set the stage providing directions for the actors to follow, the ensuring a seamless transition from a powered off state to a fully operational one. The code in the boot ROM basically instructs the read controller to read the boot blocks into the memory and then starts the execution of the code. Now, let's know about the boot process. When you power on your computer, the system starts executing the instructions stored in the boot blocks. These instructions guide the computer through a series of steps, including loading the operating system kernel into the memory and initializing essential components. Imagine it is a well choreographed dance where each step is carefully done. These boot blocks serve as the choreographer, ensuring that every process and component enters the stage at the right time and in the right sequence. Now, master boot record. Let us know about master boot record. The MBR is located in the first sector of a storage device, such as hard disk or a solid state drive. Structure of master boot record. Master boot record consists of three main components: partition table, boot code, and disk signature. It occupies the initial 512 bytes of the storage device, and it also has some limitations. Master boot record is compatible with legacy BIOS systems but has limitations, including support for a maximum of four primary partitions. Boot blocks come in different types, each serving a specific purpose in the boot process. There are a number of types of bootloaders, so let us know some of them. The first one is primary boot block. This is the initial code executed during the boot process. It locates and loads the secondary bootloader, setting the foundation for the subsequent steps. Secondary bootloader. Following the primary boot block, the secondary bootloader takes charge. It's responsible for locating and loading the operating system kernel into memory, preparing the system for user interaction. Master boot record. For systems using traditional BIOS firmware, the master boot record is a crucial boot block. It contains the partition table and the code to initiate the boot process. And the other one is UEFI bootloader. In modern systems using UEFI firmware, the UEFI bootloader takes center stage. It's a more sophisticated boot block interacting with the UEFI firmware and efficiently loading the operating system. The full Bootstrap program is more complex than the Bootstrap loader into the boot ROM. It is basically able to load the complete OS from a non-fixed location on disk to start the operating system running. Basically, for a computer to start running, to get an instance when it is powered up or rebooted, it needed to have an initial program to run. And this initial program, which is known as Bootstrap, needs to be simple. To do this job, the Bootstrap program basically finds the operating system kernel on disk and then loads the kernel into the memory, and after this it jumps into the initial address to begin the operating system execution. The full Bootstrap program is stored in the boot blocks at a fixed location on the disk. A disk that has a boot partition is called a boot disk. There are some advantages and disadvantages on the boot blocks. Coming to the advantages, boot blocks are designed to be small and efficient, allowing the operating system to load quickly during the boot process. And it also gives protection against the disk failure, compatibility with different hardware configurations, and reduced system downtime, and improved security and customizations. These are some of the advantages. And coming to the disadvantages, boot blocks can be vulnerable to malware attacks as they are loaded into the memory before the operating system's security. They can consume a significant amount of memory, which may impact the overall performance of the system. And some other disadvantages are limited storage capacity, difficulty in modifying, potential for instability, complexity of troubleshooting, and final one is compatibility with software and firmware. Thank you. Coming to the key points on the boot blocks, firstly, we'll talk about the location. The boot block is typically located at very beginning of the storage device, such as the first sector of a hard disk or the master boot record and a partitioned storage device. And the second one is bootstrap code. The boot block contains a small program known as bootstrap code. This code is responsible for loading the larger and more complex bootloader or operating system kernel into the computer's RAM. And the third one is master boot record. On systems using the traditional BIOS firmware, the boot block is often part of MBF, which is a small section at the beginning of the storage device that contains the primary bootloader. And the fourth one is bootloader. Bootloader code in the boot block often loads a more advanced bootloader, which in turn is responsible for loading the operating system kernel. And some of the popular bootloaders include GRUB, which means Grand Unified Bootloader, and LILO, Linux Loader for Linux systems, and NTLDR, NTLoader, or Boot MGR for Windows system. And the final one is security considerations. Since the block plays a critical role in the system's startup process, it becomes a target for malicious software. Malware that infects the boot block can compromise the entire system. Therefore, secure boot mechanisms such as those implemented in UEFI aim to protect the boot process from unauthorized or malicious code.